Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, we will figure out how to unleash the power of simplicity with Azure Container Instances. I will describe the benefits of Azure Container Instances and how resources are grouped. And we will see how to deploy container instances in Azure by using Azure CLI. With Azure Container Instances, or ACI, you can focus on designing and building your applications instead of managing the infrastructure that runs them. When you build container images and want to test them, ACI is the ideal tool for this. Ready in seconds, you can pull your image from Azure Container Registry or a public Docker registry and start testing your running container. ACI is using virtual machines under the hood, with a container engine installed on top. But you don't have to deal with these infrastructure components. You focus only on what goes into the container and how you want to configure the container. Containers have a big advantage over virtual machines in terms of how fast they can start. Azure Container Instances can launch containers in Azure within seconds without having to set up and manage virtual machines. ACI lets you connect your container groups to the internet with an IP address and a fully qualified domain name in FQDN. When you make a container instance, you can choose a custom DNS name label so your application can be accessed by it too. ACI provides the security benefits of virtual machines for your container workloads while maintaining the efficiency of lightweight containers. Each container group runs in isolation without sharing a kernel, ensuring robust security. You can provision ACIs with custom compute sizes tailored to your workload requirements. This flexibility allows you to allocate the right amount of resources for your application. And for saving and accessing state with Azure Container Instances, you can mount Azure file shares into it. ACI supports both Linux and Windows containers, making it flexible for various application stacks. Azure Container Instances allows you to schedule groups of multiple containers that use the same host machine, network, storage, and lifecycle. This lets you pair your main application container with other helpful role containers, such as logging sidecars or a front-end back-end combination. You can deploy ACI containers within a virtual network, allowing secure communication and integration with other Azure resources in the same network. Now, the top-level resource in Azure Container Instances is the container group. A group can consist of one or more containers. The containers in a container group share a lifecycle, resources, local network, and storage volumes. This example on the slide shows a container group that is scheduled on a single host machine. It has assigned a DNS name label, and it exposes a single public IP address with one exposed port. It consists of two different containers. One container listens on port 80, while the other listens on port 5000. It includes also two Azure file shares as volume mounts, and each container mounts one of the shares locally. It's important to understand that multi-container groups currently support only Linux containers. For Windows containers, Azure Container Instances only support deployment of a single instance. Multi-container groups are useful in scenarios where you have a container that hosts a web application and a container that fetches the most recent content from version control, as an example, or a container for the application and a container for monitoring. The monitoring container regularly checks the application by sending a request and making sure it's working and replying properly and warns if it's not. A container for the front end and a container for the back end would be another scenario. The front end could display a web application, while the backend could run a service to get data. The images can be delivered by different teams and have separate resource requirements for all of these different container instances. To deploy a multi-container group, you can use a resource manager template or an ARM template or a YAML file. A resource manager template is recommended when you need to deploy additional Azure resources, for example, an Azure file share that you would like to deploy with the ACI instance in one go. When your deployment includes only container instances, YAML is recommended. For storage, we saw that we can mount Azure file shares into containers, but ACI also supports a secret volume to supply sensitive information to the containers, empty dir volumes to share data between the containers, and Git repo volume to clone a Git repository into your container. For resource allocation, since the resources are shared by all containers in the group, you can add resource requests for each instance. Taking CPU resources as an example, if you create a container group with 2 container instances, each requesting 1 CPU, then the container group is allocated 2 CPUs in total. Would you like to see how an ACI is created? Moving on to a demo. In this video, I will show you how to create an Azure Container Instance, an ACI, out of an image that is hosted on a container registry in Azure. The container registry is what we're looking at here right now. So I have a container registry with one repository called IP checked, simple IP address printing out .NET application, and here's one version of a container image stored by the tag latest. And that image, now I would like to see if that's working okay, if that's running on Azure or somewhere else, but we tested on Azure first. So what I would like to do is create an ACI and then pull that image from here. I will do this in the command line. I have an Ubuntu session open here on a Windows system, and I'm already connected to Azure. And I use that command AZACR repository show tags to show you exactly the outcome I just showed you in the portal. So yeah, it can read the information from that repository and then print out here the latest tag of that image. So I have connection of that already established. Now, before I can use an ACI to pull an image from there, the ACI, the instance, needs access to do this, to create an image outside of that. And to allow this, I need to enable the permission, or not the permission really, but I will enable a so-called admin account on the ACR so that it has credentials that the ACI can use for this. So I will use AZACR update. I will point it to the ACR in question here, and then I will use this parameter admin user, or actually that's not user, admin enabled, and set this to true. It's by default disabled, and that's the reason why I have to enable it first. So that configuration has taken place, and now I can move on and create an ACI instance out of this. Now I will also do this from the command line. It's a little bit more to type, but I will explain what this is all about. So, and maybe I can do this while this is actually running. It's using the command AZ container create, which is creating an ACI. Then it's pointing to the resource group where we do want to have this, and it's calling that demo ACI. You can provide any name you want. The image that it is pointing to does come from the ACR that we use. We use the name that we can see here on the left-hand side as well, and just added Azure CR to the end, .io, AzureCR.io, that's the standard default domain for every ACR. And then we pointed to the image of question in question, IP check latest. The rest is the configuration of the ACI. So we're going to use 2 CPUs, 4 GB of memory, which is a lot for this application, but okay. we will use here a registry login. And that is the reason why I just had to enable this admin configuration, because within here we say you need to log into this server, you use a specific password, and I get that credential for that user dynamically now from the ACR. And then last but not least, and that's something we will see and talk about in a bit when we see that running, the restart policy of that Azure Container Registry is set to never. And I will show you what that means. So that was long enough. So it looks all good. It has reported here that it created that. All is good. And now I should see a container instance. Now, I can look at this from different perspectives. So I could say, what is the actual state of this right now? That's another command here, AZ container show. I will point it to it. And I have already a specific query in here where I'm particularly interested in the provisioning state. I want to know if this is running or if it's still building, but it's provisioned, it's succeeded, but it is terminated. It's not really a but, because that is what I was expecting, because my application does the following. So I have that application still here in .NET. So all it does, it's running just some little code, reads out the IP addresses from a local system and prints them out. And it did the same thing in the container. And since it is not waiting for anything or doing this continuously, it will print out the IP addresses of the container instance and then terminate, because it has done what it was asked to do. That is just the way that this application is handled. So it's not the perfect fit for a container, but yeah, it does its job. And if I look now at the logs of this, let me just clean this up a bit and see if we can get any logs from my container ACI. Then you can tell that this is the log from the container instance. So this is a different outcome of what I just showed you for my local system, and that is coming from the container instance itself. Let's have a look at this from the portal, so I can maybe connect these points for you together. So let's have a look for ACI. That shows me here container instances. If I open this up, here's our demo ACI. And what I can tell from here is just, with the same thing, succeeded. And let's have a look at the containers. The single container one, it has the same information obviously in here. And in the logs, I can see the same thing. So this is where that information is coming from. And the reason why I changed the restart policy to never is I just wanted this to happen once and not continuously. I could change the policy to always, which would mean I would constantly see this being increased by 1. So it will be running again and again and again and again. Every time it's terminated will be again. And that is just the configuration piece that I did with this setting that we had used before. Maybe I can show you this one last time here, and then you can have a look at this again. Normally, the restart policy is set by default to always, if I'm not mistaken at that point, and you can either set it to never, always, or on failure. So if the instance for some reason crashes, you can let it start once, or you can let it start all the time. Now in this first unit, I described the benefits of Azure Container Instances and how resources are grouped together. I also showed you how to deploy a container instance in Azure by using the Azure CLI. In this unit, we will learn how to configure environment variables, restart policies, and persistent storage for an Azure Container Instance. I will show you how to start and stop containers using policies, how you set environment variables in your container instances, and how to mount file shares in your container instances. The behavior of how container instances start or stop is controlled by the restart policy setting of a container group. You can change the default behavior by manually starting or stopping a container group at any time. The 3 options you can set are: first, always. Containers in the container group are always restarted. This is the default setting applied when no restart policy is specified at container creation time. Never. Containers in the container group are never restarted. The containers just run at most once. And on failure, containers in the container group are restarted only when the process executed in the container fails, meaning it has terminated with a non-zero exit code. The containers are run at least once. Environment variables provide dynamic configuration of the application or script running in your container. In this example, two variables are passed to the container when it is created. ACI supports both Windows and Linux containers to pass secrets as environment variables. In YAML, you can set variables in two ways. Using the value keyword, the value of my exposed value here can appear in command line outputs or logs. When you use the secure value property instead, the value will be protected from that kind of exposure. If I run an AZ-CLI command to query all environment variables and their values, the response would only show the insecure values, and for the secure ones, I'd see null instead. By default, Azure Container Instances are stateless. The container state is not saved if it restarts, stops, or fails. To keep state after the container is gone, you need to attach a volume from an external store. The next demo shows how Azure Container Instances can attach an Azure file share made with Azure Files. In this video, I will show you how to mount a file share into an Azure Container Instance. And for this, I will use the approach that I'm not using one that I already have, but I will show you the full process how to create a storage account with a file share where we store the data, so we have a persistent storage for our ACI, and then mount it into another ACI at the creation time. In order to do this, I have the lines already here, so you don't have to watch me typing. This is also coming from a Microsoft Learn tutorial. You can see the link on the top of this side, and I'll explain each of the steps when we go through this. How do I do this? This is a file that is on my local machine, and I have already connected to my Azure Cloud Shell with a bash session that is open, so I have access to the subscription I just showed you in the portal. And all the different commands I'm running right now will be executed in that Cloud Shell. So we start off by just defining some variables. We will use the Contoso app resource group. That application or the ACI we're going to create will be named Contoso app ACI with a random number to it, and it will go into the East US region. So let me just fire this up so that the Cloud Shell is aware of this. And then the first thing we do is we create a storage account. The storage account will go into that resource group, and I will just give this that name, and we will use this to store the file share in it. The file share is a service that is part of a storage account, and in the file share we can then use this to upload files, mount this into an operating system, be it Windows, Mac OS, or Linux. Now, storage account is created, and the next thing I will do is to create a share inside of that storage account. So we will referencing the just existing or the just created storage account. So I will run this line to create a file share by a name, and that was really fast. So now it's done. Now for the next steps, we need to get the credentials ready. So first of all, just to echo this out one more time, we have the Contoso app ACI 1448. That is the name of that specific ACI that we have now created. And now I need to have the storage key, because the ACI needs to have a way to access the storage account's file share and have the rights to read or write data from there, depending on what we want. And in this scenario here, we will get the storage or the access key, one of them in here. So I will run this line and store the access key in this variable storage key, and it gives me already here a warning saying, yeah, you should not expose this somewhere. It's a secret, and anyone or anything that gets that at hand will be able to access the storage account with it. So we should handle this with care. I will do this and not echo this out right now. Then in the final step, now we have a file share. That's the only thing we did right now in a storage account. Now I would like to create a container instance in the same resource group. They will be called hello files. We use a specific image out of the Microsoft Container Registry that is called ACI hello files. It's a specific, you will see it's a website that allows us to create files in that website that will be stored then in the persistent storage. It comes up with a specific label that I have chosen here. I can access this as a website, and it's using this command Azure file volume account name, which means this is where we mount the file share from. And here is the share name that we will use in there, and the path will be using this ACI logs folder for that one. Now let's run this, and it's a multi-line command that will take a minute or two. ACI created. Now let's check this out. So we go back to the portal, and now if I refresh, you will see I have another instance right now with all the different characteristics we talked about. It's still not completed apparently, so it's still in pending status, but that will change in a few seconds. And if I open this up, let's check if the status already at running. Yeah, that's perfect. Now it is in the state I want it to be. And let me show you that website I was talking about. Now I take the FQDN that I have configured here and put it into a tab of my browser, and you will see that running this for the very first time, it might take a while until that is actually answering. While this is going on, I can still check in the containers tab here the logs and see what's going on. It is apparently not completely configured yet, so let's just give it a couple of seconds. It might take a little longer for me to be able to connect to this. And it's the first time that this is starting up, so let's try again. And there it is. So this is the website that I was showing. This is part of the image that you get from the Microsoft Container Registry. And what I can do now is to put a file in here, or put text in here, string, and it will be saved as a file. Before I do this, let's have a look in the split view here, where I can show you the file share. So the file share, I can look for the storage account that we have created. That's the one here. I showed you the name earlier. So if I open this up, I go to the data storage area where I see the file shares. And if I open this up, here is our ACI share that was just created. And this is of course empty right now. There's nothing in there. So if I click on browse, you will see no files there. Now let's go ahead and we add something. What will we add? Obviously the hello world example. So let's create one file. Let's create another one because we haven't completed this. So let's click submit. Now let's refresh, and yeah, I see two different files in here. Now I cannot, there's no editor in here. I can now choose either to connect to the file share, or I could go ahead and download this file and then check what is in it. And yeah, that's the first one, that is the hello. So yeah, so the cycle works. I have all the different files in there, and that really is how easy it is to mount a persistent storage using a file share in your container instances and use them for configuration logs or whatever other kind of storage you need to have in your Azure Container Instances. In this video, you have discovered the agility of Azure Container Instances for rapid container deployment. By mastering environment variable configuration and container restore policies, you are equipped to deploy and manage containers with unparalleled speed and efficiency. Embrace the simplicity and speed of Azure Container Instances for seamless container deployment in your projects. Thanks for watching. Keep on learning.